Question: draw the Lewis structures for the following molecules. 1. Carbon 4 oxide. 2. Hydrogen sulfide. 3. Boron trifluoride. 4. Ammonia. Solution: Lewis structure for carbon 4 oxide is as shown, where you have each of the atoms surrounded by 8 electrons. For you to draw a Lewis structure, first you must know the valence electrons in each of the atoms involved in the molecule. So here we have oxygen, which belongs to group 6 in the periodic table, and it has 6 valence electrons. We have carbon atom here. It belongs to group 4 in the periodic table, and it has 4 valence electrons. And oxygen, which I've already said, belongs to group 6, and it has 6 valence electrons. Now, what is the total number of electrons in carbon 4 oxide? For carbon, we have 4 valence electrons because it belongs to group 4. For oxygen, we have 6 valence electrons because it belongs to group 6. And we have 2 atoms of oxygen in carbon 4 oxide. So that is why we now multiply 6 times 2 to give us 12. So 12 plus 4 will now give us the total number of electrons in carbon 4 oxide, which is 16. So now, Lewis structure is just a way of showing how electrons are being arranged in the molecule. So we have a total of 16 electrons, and this is how the 16 electrons are being arranged. So if you count the total number of electrons here, it will be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is the Lewis structure for carbon 4 oxide, where each of the atoms are surrounded by 8 electrons to attain octet. So if you look at this oxygen atom, 8 electrons surrounds it. The same thing applicable to this carbon atom. We have 8 electrons surrounding this carbon atom, which are 1, 2, 3, 4, 5, 6, 7, 8. Then the same thing to this oxygen. The electrons that surround this oxygen are 8 in numbers, where we have 1, 2, 3, 4, 5, 6, 7, 8. So the total number will be 16. So this is the Lewis structure for carbon 4 oxide. Then we have another molecule here, which is hydrogen sulfide. In hydrogen sulfide, we have sulfur atom and we have hydrogen atom. Sulfur atoms belongs to group 6 in the periodic table, and it has 6 valence electrons. Then hydrogen here belongs to group 1, and it has 1 valence electron. So we have, for sulfur, we have 6 valence electrons. Then for hydrogen, it has 1 valence electrons, and we have 2 atoms in hydrogen sulfide. So we now multiply 1 by 2 to have 2. So 2 plus 6 to give us the total number of electrons, which is 8. So now you have to show how these 8 electrons have been arranged in the molecule. So if you count the total number of these electrons, they are 8. So this is how the 8 electrons have been arranged in this molecule. You see the sulfur atom, 8 electrons surrounds it. Hydrogen, 2 electrons surrounds it. Why is it 2 electrons that surrounds hydrogen? It's because hydrogen needs 2 electrons to completely fill its outermost shell. So this is the 2 electrons. So this is the 2 electrons. So 8 electrons for this sulfur. So this is a Lewis structure for hydrogen sulfide. They also have another molecule here, which is boron trifluoride. In boron trifluoride, we have 3 atoms of fluorine and we have 1 atom of boron. Boron, as we know, belongs to group 3 in the periodic table, and as such, it has 3 valence electrons. Fluorine belongs to group 7 and it has 7 valence electrons. But in boron trifluoride, we have 3 atoms of fluorine. So that's why we now multiply the number of valence electrons by 3 to have 21. So this 21 plus 3 give us a total number of 24 electrons. So these 24 electrons will be shown how it's been arranged in the molecule. So we have fluorine here surrounded by 8 electrons, another fluorine here surrounded by 8 electrons, another fluorine here surrounded by 8 electrons. Then boron, that is at the center, is surrounded by 6 electrons. Now let's look at something about this boron. It's just surrounded by 8 electrons instead of 8. It means we have some elements that cannot accommodate up to 8 electrons. For instance, this boron, it has only 6 electrons. So this is an exception to octet rule. So we have exceptions to octet rule. So one of them is this element that cannot accommodate up to 8 electrons. So one of them is boron. So the total number here arranged in these molecules are 24 in number. If you count all, 8 is here, 8, 8. So 8 plus 8 plus 8 give us a total number of 24. So this is the Lewis structure for boron trifluoride. Then we also have a common one, which is ammonia, where we have nitrogen and we also have hydrogen. So here, nitrogen belongs to group 5 and it has 5 valence electrons. Then hydrogen also belongs to group 1 and it has 1 valence electrons. But in ammonia, we have 3 atoms of hydrogen. So that's why we multiply the valence electron by 3 to have 3. So 3 plus 5 to give us the total number of 8. So you have to show how these 8 electrons are being arranged in this molecule. So this is how the 8 electrons have been arranged. So if you count the total number of electrons here, they are 8 in number. Nitrogen is surrounded by 8 electrons. Hydrogen here, I've told you, need a maximum of 2 electrons to completely fill its outermost shell. So these are the 2 electrons that surround this hydrogen, 2 electrons that surround this hydrogen, 2 electrons that surround this hydrogen. They also understand the fact that one of these electrons, one is from hydrogen and this one is from nitrogen. The same thing here. So they share these electrons for them to form a covalent bond in between them. So this is the Lewis structure for ammonia molecule. Thank you for watching. Please remember to subscribe for more questions. Thank you.